Elon Musk revealed that Neuralink implanted a wireless brain chip. Tech billionaire Elon Musk said his company Neuralink has successfully implanted one of its wireless brain chips in a human. In a post on X, formerly Twitter, he said the procedure showed promising brain activity and the patient was recovering well. The company's goal is to connect the human brain with computers to help cope with complex neurological diseases. A number of competing companies have already introduced similar devices. For any medical device company, a first human trial is a significant milestone, said Professor Anne van Hoestenberg from King's College London. To the brain chip implantation community, we need to place this news in the context that while there are many companies working on interesting products, only a few other companies are implanting their devices in people. So Neuralink joins a fairly small group. However, she also suggested that caution must be exercised, as true success can only be measured over the long term. We know that Elon Musk is very good at advertising his company, she added. Other companies that have achieved similar successes in this area include the École Polytechnique Fédérale de Lausanne EPFL, Switzerland, which successfully enabled a paralyzed man to walk simply by thinking. This was achieved by installing electronic implants in his brain and spine that wirelessly transmit thoughts to his legs and feet. Details of the breakthrough were published in the peer-reviewed journal Nature in May 2023. There has been no independent verification of Musk's claims, and Neuralink has not provided any information about the procedure it says took place. BBC News has approached Neuralink and the US medical regulator, the Food and Drug Administration (FDA), for comment. Neuralink testing Neuralink has come under criticism in the past, with Reuters reporting in December 2020 that the company conducted tests that killed around 1,500 animals, including sheep, monkeys and pigs. In July 2023, the head of the US Department of Agriculture, which investigates animal welfare issues, said it had found no animal research violations at the company. However, a separate agency investigation is ongoing. Musk's company received permission from the FDA to test the chip on humans in May 2023. That green-lighted the start of a 6-year study in which a robot is used to surgically insert 64 flexible threads, thinner than a human hair, into the part of the brain that controls movement intention. According to Neuralink, the company says these threads allow its experimental implant, powered by a battery that can be charged wirelessly, to record and transmit brain signals wirelessly to an app that deciphers how a person is going to move. It has great potential to help people with neurological disorders in the future and is an excellent example of how basic neuroscience research is being used to advance medical goals, said Professor Tara Spires-Jones, president of the British Association of Neurosciences. However, most of these interfaces require invasive neurosurgery and are still in the experimental stage, so it will likely be many years before they are generally available. Telepathy. In another post on X, Musk said Neuralink's first product will be called telepathy. Telepathy, he said, will make it possible to control your phone or computer, and through them almost any device, just by thinking. The initial users will be those who have lost the use of their limbs, he continued, referring to a late British scientist who had motor neurone disease. He added, "Imagine if Stephen Hawking could communicate faster than a typist or an auctioneer. That's the goal." While Musk's involvement raises Neuralink's profile, some of its competitors have track records going back to decades. Utah-based BlackRock Neurotech implanted its first of many brain-computer interfaces in 2000 for Precision Neuroscience, created by the co-founder of Neuralink, also aims to help people with paralysis. His implant resembles a very thin piece of tape that attaches to the surface of the brain and can be implanted through a cranial microslit, which he says is a much simpler procedure. Existing devices have also produced results. Two separate recent scientific studies in the US used implants to monitor brain activity when a person tried to speak, and this information could then be deciphered to help them communicate.